What are binary operations in mathematics? The first thing is, what are binary operations? We will try to understand the words first. Binary, it consists of bi and an array. Bi means 2. So that means in binary or bi, there will be two values, two operands actually. And they will operate, there will be certain operation. So what are these operations? This can be any mathematical operation. But in the case of binary operation, let me write 2 into 3, 2 multiplied by 3, 2 plus 3, 2 minus 3, and 2 divided by 3. So these are the operations I am talking about. Into, plus, minus, divide. So the first operand is 2, second operand is 3, that means it is by 2, binary. And these are the operations. That is what is called as binary operations. These are 4 operations possible in binary operations. Now let us generalize it. What does it mean? Generalizing means, see, we will start with a set. Everything starts with a set. The set R or set is the combination or collection of interrelated items, values. So let us write a set S or A like this. This is 1, 2, 3. It can be any set. So this 2 and 3 is coming from this set. That is the two operands. By means two operands are coming from this set. So what do you get? 2 into 3 is 6 and 2 plus 3 is 5. But this 6 and 5 is not in this set. So this is not a binary operation. Because for the binary operations to hold, the resultant value of the operation should be inside that set only. That is, you take two operand from the set and now the operated value should be in this set. For example, I am increasing this set. 1, 2, 3, 4, 5, 6. So see, the 2 is coming from this set. 3 is also coming from this set. And the result, which is 6, is also coming from the same set. Similarly with the plus also. 2 and 3, when added, you get 5. 5 is also coming from this set. So the two values in the result should come from this value. I'm not talking about 2 minus 3 and 2 divided by 3. We'll talk about it later because it is not forming actually the binary operation right now for this set. So how do we write it? You can write it as set S, or rather you will see everywhere in the books it will be demonstrated as A. So I'm writing A because two operands are coming from A, the second is also coming from A, and the resultant is also from A. So we define all these operations are there, so why not to have a single common symbol to depict these operations. So let us say it is star. You will see we'll use O and cap, various symbols we are going to use. For now we are using the star. So the first value is coming from this set A, that is, for example, here 2 is coming from A. So the second value is coming from A, so how much the Cartesian product, so A cross A. Then this is called as the domain. Then the final value, resultant value is coming again from A, which is called the codomain. And this star is what? Is all the operation, we just called it as one symbol star. So one value, second value coming from the same set, result is also going to the same set, or it is coming from the same set. We'll not talk about 2 minus 3 divided by 3 because 2 minus 3 is minus 1, 2 divided by 3 is 2 by 3, and this is not going in this set. So 2 minus 3, 2 divided by 3 for this is not a binary operation. I'll tell you how to make it. So now how to write it? The writing is, we have to depict the domain, the codomain. This A cross A is domain, A is a codomain. I'm not talking it as a range. What are the properties of binary operations? Binary operation means what? Bi means 2, operation means any kind of mathematical operation, but in binary operation we only define plus, minus, divide and multiplication. So in order to understand the properties of binary operation, which a binary operation should hold, is, let us say we have a set A. The first value has to be taken from this set. Let us say it is A. The second value is also taken from this set. Let us call it as A. Now we operate, we are calling star as a symbol. And the value C, which is coming after the operation, should also belong to that set A. So this is nothing but the closure property. Closure property, that is an operation star on any non-empty set. A non-empty set means the set A has to have something. Has closure property because if A is belonging to this set, the B is belonging to the same set, the C should also, that is the result of this A cross B or A star B, that is the operation of A and B, should also belong to the same set. This is called the closure property. Now there are different type of sets which we have defined in our set discussion. For example, you can have value 2.3, 2 by 3, all these belongs to different sets. One is the higher set, one is the lower set. For example, we have the natural numbers represented by n, z is represented for integer, and we use the symbol q for rational numbers, the real numbers r, and complex number c. So when we are talking about addition, a plus b, this star I have replaced by plus, so a plus b. And when we are talking about this a plus b on natural number, on integer, on rational number, on real number, on complex number, this holds. So this holds, that's the addition holds. That is the first value we have taken from natural number, second also value we have taken natural number, and when we add these two values, the resultant value should also go or come from the natural number. So the addition for all these are true, but not for irrational number. The additions on the set of all irrational numbers are not the binary operations, right? So if I am saying a plus b, n, z, q, r, c, for this set, it holds, this property hold. But for the irrational number, for example, what is the irrational number? I'll just give you an example. For example, under root 2. This is the irrational number. So when you're adding two irrational number, it may or it may not be coming from the irrational number. This may happen. So the same discussion we are going for the multiplication. Same thing. So let us say for multiplication, and let us try to understand what all are possible. That is, we are talking about natural number, the integer z, the rational number q, and the real number r, and the complex number c. So let me change it, 2 r's I have written, I'll just change it. But first value I am taking from any of this set, second value I am taking from any of this set. The resultant value should go to that set which we have defined, from where taken. For example, this natural number, integer, rational number, let us make it as q to be more precise, q for quotient, and the real numbers and the complex number. Let us say a we have taken from real number, b we have taken from real number, and we multiplied these two numbers. The result should be from the real number. It should be in this set. So the multiplication is also holding here for this n, z, q, r, c, but multiplication is not valid for irrational number. It's not a binary operation. Then we have the subtraction. Subtraction is a binary operation. On which set? The integer, the rational number q, the real numbers r, and the complex number. So what are where did the other sets go? Because the subtraction only holds for all these. For example, the subtraction doesn't hold for the natural number. The binary operation subtraction doesn't hold. Because if you take a from natural number, b from natural number, the result may or may not be in the natural number. Therefore, it is not a binary operation on natural number. For example, if I take a as 1, b as 2, 1 minus 2 is negative 1. Negative 1 is not in the natural number. Natural numbers are counting numbers. Remember? For z, q, r, c, this subtraction works. Coming to division. Now let us see which are the sets for which division is a binary operation. So the division is not a binary operation on the set of natural number, the integer, the rational number, real number, and complex number. Then the exponential operation, that is x to the power y. So this is a binary operation on the set of natural number, but not on the set of integers. Please remember, I'm just talking about exponential, that is x to the power y. So it is a binary operation on the set of natural number and not on the set of integers. The types of binary operation or the properties of binary operation. The first one is commutative. The word has come from commute. Commute means going from one place to another or moving. So when we say we have a binary operation, say it is a star, and we are operating or we are trying to find out the binary, bi means two values operands from a set A. So we are taking A from this set A and B also from this capital set A, and we operate. So the A cross B should be equal to B cross A. That is, if we commute A and B, change the position of A and B, it should be equal. So let us take an example. And because this star has to be given some value, either negative, positive, division or multiplication, so let us take it as plus. So any set you can take. I'm just taking a random set and I'm saying that A is 8, B is equal to 9. So A plus B is what? It's 8 plus 9, which is equal to 17. And now commute it. Let us take now B plus A. So B plus A will be what? It's 9 plus 7, 9 plus 8, and that is also equal to 70. That is, it is commutative. Now coming to the second property or type of binary operation, which is the associative. So associative means, see, first you associate with someone else and the result should be associated to the other one. So the associative property of a binary operation, when it holds on a set A which has to be non-empty, that is, a set has to have some value, then we are taking a set A, capital A, and from this we are picking up three values, say small a, b and c. And what is star? You know, star is an operation. So A star B star C, we have to take A star B first and the result has to be operated with C. The result should be equal to A star B star C. That is, now here first we will operate B and C and then the result will be operated with A. Okay. Now again we are taking the natural number set and we'll try to take an example. And multiplication will be the binary operation here. So take any ABC value from natural number. I am taking A as 4, B as 5 and C as 6. So what are we going to do? We will do the operation like this, but first we will operate 4 and 5. Then the result will be operated with 6. So what will be the value? 4 into 5 is 20, 20 into 6 is 120. Now the same thing will be done with A, B, C, but now here first we'll operate B and C and then the result will be operated with A. So previously we did 4 into 5 first. Here we are doing 5 into 6 first. 5 into 6 is 30, 30 into 4 is 120. So this is called the associative property or associative type of binary operation. Next property is the distributive property. The distributive property is how you distribute two operations. Now why I am saying that? Because in distributive we need two operations. We defined the operation, binary operation, as plus, minus, division and multiplication, and we took a common symbol star. But we have to take two symbols here in order to prove or to depict, to represent the distributive property. So what we are doing here is A star, because this is the first operation. So A star, and we have to use another operation, so we cannot use this star. So let us say we are using another representation or symbol of operation which is called as O. Because I am taking A plus B minus C. So plus and minus are not equal. So I cannot represent plus and minus both by star. I have to take some O for the negative. Okay. So for two operation, we are saying one we will take as star, other you can take it as anything you want. I am taking it as O. O is not suitable because it is a letter. So we should not use it, but most of the books have been using it, so I am using it. A star B operation C. So distribution means opening and giving it to everybody, operating to everybody. So A star B operation C, it means A star B operation A star C. That means I am distributing the star over O. So A star B and then A star C, and the final operation in between them will be an operation O. Right? This is called the distributive property. Let us take the example also. Let us consider the star is multiplication and O is subtraction. Remember, we have to take two separate symbols in order to represent two separate actual operation. So A we are taking as 2, B we are taking as 5, and C we are taking as 4. So 2 into 5 minus 4. So we'll try to find out this value, and also on the right hand side it will be A, that is 2. Let us take the value directly, okay. So 2 into 5, operation is what? Inside negative, and then we have 2 into 4, 2 multiplication of 4. So 2 cross 5 minus 4, 5 minus 4 is 1, so 2 into 1 is what? It is going to give you 2. What is here? 5 into 2 is 10, minus 4 to 8, so 2. So the distributive property is also holding here. Now the identity. So this is also a property, this is also a types of binary operation, identity. So there will be an identity, and when the identity exists, there will be inverse. For inverse to happen, there has to be some identity value. Okay. Remember, everything is happening on a set. So you have to be very careful about and understanding about the set. So let us take, we are taking a set A, and star is our operation, right? Okay. So there will be some element, let us represent it by E. There will be an element E. And when it will be called as an identity element, when we operate A with E, that is, you take any element from capital A, that is, I am taking small a, and we are operating E on it. So when we are operating means I am not using into, I am using star. This is star. This is not multiplication, this is star. So A operation E, or I am taking another value which is B into B operation E, you will always get the actual value which is A and B. So all these operation on this certain value E on the same set A. So when we operate A with a certain value, you get the same value. For example, addition. So A plus is the operation, you have to put certain value so that you get A again. So 0 here in the case of plus is the identity value. How about multiplication? What you multiply with certain value to get the same value? You multiply it by 1. 1. So this 1 is the identity value with respect to multiplication. For addition, the identity value is 0. Multiplication, identity value is 1. Coming to inverse. Now, when we have inverse, we need to have identity. Okay. So when we take two values, remember we are taking the values from a single set, and the result also has to go to the same set. That is the binary operation prerequisite. Okay. A operation B, when you do it, and you do B operation A, you are getting the identity E. E can be, you can represent it by I, E, whichever symbol you want. So A cross B, B cross A, you are getting E. So B is the inverse of A is the inverse of B. That is, A inverse is B and B inverse is A. How does it happen? I am saying that when we take in multiplication, that is A into B, A multiplication B or B multiplication A is equal to E. And for multiplication, what is the identity? It is 1. So A into B, you can write it as 1. So A will be equal to 1 by B, which is equal to, also B into A equals to 1 B is equal to 1 by A. So A will be B inverse, B will be A inverse, vice versa. Okay. Binary operation table. So binary operations are what? Bi means 2. So there will be two values, or we can call it as operands. There will be some operation inside it, that is plus, minus, division and multiplication. So you have value A from set capital A, value B from capital set A, and when we operate, you are getting a value which also has to belong to that same set. That is the binary operation. So this binary operation table is a visual representation of a set where all the elements are shown along with the performed binary operation. This can be any binary operation. So you can perceive, it's visually very overwhelming. You can easily see what is happening where, rather than writing one by one line. So here we have a set. For example, we are taking set as 1, 2, 3, 4, 5. This is our set which we'll be discussing. And there will be an operation. You can call it as a star, you can call it as O, you can call it as a cap. So we are taking the operation as cap. So when we are trying to represent a binary operation as binary operation table, so how do we write? This cap, which is actually operation, is such that S cross S, that is the first element is going from this set, second element is all going to come from this set, and there will be an operation on this set, and the result is going to be from the same set, S. So we are calling a table because we have the rows. The direction I'm showing is the direction of the rows, and the vertical lines or vertical, say, bars, these are called as the column. The horizontal rows, vertical columns. So A cap B is what we are representing. A can be 1 to 5, B can be 1 to 5. For example, let us take an example. This 3. Okay, we have 3, and let us take from here 4. So 1, 2, 3, 4, 5. This is also a set A or S, you can call it. And this also is a set, same set. So we are picking a value A. In this case, I'm taking 3. We are taking a value 4, which is B actually. As B, we are taking 4. So just take the vertical and horizontal intersection point. This is 1, and which is the resultant. And please remember, 3 cap 4 or 3 operation 4 is equal to 1, and 1, 3, 4, they all are belonging to the same set. In any binary operation, we have different properties. So there are certain binary operation, and we need to have certain properties and types. So let us start one by one. Whichever you operate, 1 operate with 1, 1 operate with 2, 2 operate with 3, you're always getting certain value. For example, I'm just rounding now 3 operation 4. So all these values are coming from which set? Set is 1, 2, 3, 4, 5. So 2 values taken from the same set, the final value is also going to the same set, coming from the same set. So this is the closure property. So we have a set A which is in the row. This is also a set, same set, which is in the column. And any 2 values picked up, the resultant value will also be from the same set. So it's a binary operation. Since it is shown in the tabular form, it is binary operation table. So I'm talking about the set S, which we have already discussed, 1, 2, 3, 4, 5. And this is the row, all the values are written in row and the column. And there will be the operation. Since all these values which you see in the table are from 1 to 5, so this is a closure property. Let us take the associative property. Take any value. Let us take A as 1, B as 2, C as 3. So I'm trying to show you the associative property. How does it work? So A is 1, B is 2, C is 3. Associative property means the operation should be like this. That is, when we associate, say, A operation, B operation, C, first we do B operation C resultant with the A, or we do A star B star C, first we do A star B, and then the resultant will be operated with C. So we are taking the values now, 1 cap, 2 cap, 3. So 1 cap, 2 cap, 3 is going to give you what? 2 cap 3. Okay. Now go to the table and see what is 2 cap 3 first. That is horizontal, you will take 2, vertical, you will take 3. So 2 from here, 3 from here, what is the resultant value? 1. So you are going to get 1. Now 1 was already there outside, so 1 cap 1 is what? 1, this 1, so the cap is 1. Okay, this is the first part. Now we'll take the second part. That is A star B star C. So 1 cap, 2 cap, 3. So first we'll do the 1 cap 2. So take 1 from the horizontal, 2 from the vertical. So 1, 2 is 1, resulting is 1. Outside we have 3, so 1 cap 3. 1 cap 3 is going to give you what? It's going to give you 1. So what do you get? 1. So in both the way you are getting 1, 1, so it is associative also. The next property we will try to ponder upon is the commutative property. So commutative means A cap B should be equal to B cap A. Okay, we are computing, we are changing the position of A and B. So let us take A as 3, B as 4. You can take any value. I'm just taking A as 3, B as 4. So this is 3 from horizontal, 4 from vertical. The result is 1. B cap A. Now you take B as 4, A as 3. So horizontal you will take 4, vertical you will take 3. And what is the result here? 1. So in both the cases, you are going to get the result as 1. Right? So 3 cap 4, 4 cap 3 is 1. So the commutative property is also holding here. Next property is the identity element. Identity element, in order to find the identity element of a given operation, we need to find an element E or any I which satisfies the equation A operation E, in the case we are using operation as cap, equals A. So operation with any E should also give you the actual value. So if you see here, 1 cap 1 is 1, 2 cap 1 is also 1, 3 cap 1 is also 1, 4 cap 1 is also 1, 5 cap 1 is also 1. So 1, 2, 3, 4, 5, when you are doing cap or operation with 1, you are getting the original value. Or you can say you are getting the 1 value. So what do you get? This identity element is 1 here. 1 is the identity element. Then we have the inverse property. So in order to have the inverse property, we need to have the identity. So inverse property is all about showing a pair, A operation B and B operation A, when it gives you identity element or identity from the same set. A and B and E should be from the same set. So A cap B and B cap A is going to give you E. What does it mean? It means A and B are inverse pairs. A is inverse of B, B is inverse of A. Right? We already know that 1 is the identity of this particular table or this set. So 1 cap 2, 2 cap 1. 1 cap 2 is what? 1. And 2 cap 1 is also 1. 1 cap 2. You see from the table, 1 cap 2 and 2 cap 1. They both are 1. That means the 1 and 2 are the inverse of each other. You can also do 1 cap 3 and 3 cap 1. You'll also see that this will also give you 1. And you can go on like that to actually confirm that inverse property actually hold, and one is this one was the identity and inverse property hold here. In binary operation, there are certain hidden facts which we need to understand, and we'll understand it by the means of questions. So how many number of binary operations are possible on a set A? This is equal to n to the power n square. How we are getting it? We'll try to find out also. We'll try to understand with an example. So let us say we have a set A, 1, 2, 3. We have to find the number of binary operations on A. Before going to this, let me give you a background. We have a set A and we have a set B. Let us say A has 3 values, 1, 2, 3. B has 2 values, 4 and 5. Okay. So B has 2 elements, A has 3 elements. So how many number of binary operations are possible? 2 to the power 3. So this is A is the domain and B is the codomain. I'm not talking as a range. So codomain to the power domain is the actual number of operations possible. In order to find out the number of binary operations possible, we'll use the same logic. That is, when we represent A cross A, you remember this star, colon, A cross A, arrow A. What does it mean? The first value is taken from the same set. The second value is also taken from the same set. So there will be a Cartesian product, A cross A. Now here let us say we have A set has n element. The result also should have this n value. Okay. So when we have A cross A, that is we have a Cartesian product n cross n. Because the both A and A, that is the A cross B, should come from the A cross A, that is the Cartesian product. So n square, n into n is n square. So n square are the possible values of the domain. How about the codomain? It is n because A has n element. So as I said, codomain to the power domain. So you have codomain as n, and the n square is the domain value. So n to the power n square. That is how it is formed. Now let us try to actually find out the actual value. So we have a set A, which is 1, 2, 3. Okay. So we have 3 elements here. Number of element is 3. What is the formula? N to the power n squared. So 3 to the power 3 square. What is this? 3 square is 9. So it is 3 to the power 9. So I'm just trying to tell you how we got to the formula n to the power n square, and this is how value are found. I hope you will be able to find out 3 to the power 9. So this is the whole idea of number of operations which are possible on any set A. Show that the division is not a binary operation in n nor subtraction in n. N is a natural number. Natural number are the counting numbers. Okay. So we have to show that it is not a binary operation in n and neither on subtraction. So natural number is our set. As I said, these are the counting numbers. So it doesn't start with 0. It will always start with 1, 1, 2, 3, and it goes up to infinity. Natural number always go up to infinity. So 1, 2, 3 like that. So we will pick one value from this natural number set, other value also from the natural number set. That is, we are taking A from this set, B from this set. Okay. So we are taking A from this set, B from this set, and whenever the operation will be there, the final value will also belong to this set, if it is a binary operation. So first we'll take the division. So A star A should give you A, that is n cross n should give you n. One value we are taking from natural number, other also from the natural number, third has to be belonging to the natural number. We are going to check it. So when we take the division, it may not be possible. Okay, that is, we are taking the first value and the second value, the by value, that is the binary, and when we operate it using a division operator, that is n is 1, 2, 3. So if you take A as say 5, I'm just taking random value. You can also pick any random value. So I'm taking A as 5 and B as 3. You can also take A as 3 and B as 5. You will prove it here also. What about A cross B? Cross, I'm saying we have to check for division. So A divided by B. The operation is division. So A division B, that is 5 division 3 is going to give you, which is divide 3. 3 ones are 3 and you get 2. This is 20. 3 is 6. So 1.666 it will come. So you get a decimal value, which is not a natural number. So the division is not a binary operation in n. Second case, we will check for the subtraction. So same operation we are going to do, same thing. But here A cross B, which is the A operation of B, in the case of operation, we are going to take a negative value, minus A minus B. Okay. So n is 1, 2, 3, 4, 5, 6. Any value you take, we are taking the natural number because the question is also asking about the natural number. A minus B. A I am taking as 3, B as 2. So 3 minus 2 is 1. It belongs to natural number. But let us reverse this. Let us take 3 and 5 again. 3 minus 5 is negative 2. Negative 2 is not belonging to natural number. Are all binary operation closed? First of all, you have to understand what is close. Close means it has to follow the closure property. That is, the value when operated, the final value should also go to the same set, come from the same set. Is it possible? Many sets which we are familiar, they are closed under binary operation. Certain may not be. For example, I am taking a set and I am saying that this set is a set of odd integers. Not integers, odd integers. That is those values which are not divisible by 2. So let me make it as a proper set. I'm just crossing it because I have to include the negative value also. So negative 5, negative 3, negative 1, and then 0, 1, 3, 5 like this. This is the set of the odd integers. So when we do the multiplication, say 5 into 3, you get 15. 15 will lie here in the same set because 15 is an odd number. What about addition? For multiplication, this closure property holds. But when we change the operation 3 into 5 to 3 plus 5, and it is going to be 8. And you know what is 8? 8 is not an odd number. It is an even integer. So the binary operation are not always closed. Is square root a binary operation? The binary operation means by. By means there has to be two operands. Unary means only one operand is or one value is required. Because if you are writing a plus b, a and b are two values, a minus b, a into b. So there the plus minus division only works on two values. So that is binary operation. But what if I take under root a, under root b? I'm not using two values, only one value. Under root a is only one value. So a non-binary operation, as I said, where we require a non-binary require one number. Binary should always have two numbers. So this addition, subtraction, multiplication, division, these are the binary operation. But this under root or the factorials, these are not the binary. They are unary operation. For example, the factorial of 3. 3 into 2 into 1. We just need 3. We don't need two values. So factorial of a, factorial of b, factorial of so under root of 36. These are all unary operation. What is the identity element in a binary operation? Identity element is that value from the set when we apply the or when we operate it with certain value, that value should come. I'm saying a set is A. We have some A or B value we have picked up from the set. And the E is the identity element. When we apply, A should come, B should come. That is the same value should come back. Or there will be no change to the actual value when it is operated on an identity element. Identity element is, it is a mirror. It will show the same value. So an identity element or a neutral element also we call it as is a binary operation, and it refers to a special kind of element of a set with regards to the binary operation on that set that leaves an element of the set unaffected without any change when combined with it, when operated on it. Because if you take 2 multiplied by 1, you get 2 again. So 1 is the identity. You multiply 3 with 1, you get 3. So 1 is the identity element. Okay, this is all about this discussion. Thank you so much. Take care of yourself.